Today we're going to be studying zero and negative exponents. So let's look at the rules for zero exponents. The zero power rule of exponents states a to the zero equals 1. That is to say, any number or any variable to the zero power equals 1. Now, a very common mistake is something to the zero power is 0. It's not. It is 1. Anything to the zero power is 1. Now let's look at this. A cubed over a cubed. Now we know that anything over itself is what? Anything over itself is 1. We've studied that before. But let's solve this using the methods that we previously discussed. Let's use the quotient rule, and we will have a cubed minus 3. Now 3 minus 3 is going to be 0. A to the 0 is 1. So either way you do it, you're going to end up with 1. But just remember that rule. Anything to the 0 power is 1. Let's look at another example. Now this example is different than the example that's in the book, but there are some things in my example that I want to show you that are not in the example in the book. So let's look at the zero exponent. There it is. And what is a zero exponent associated with? It's not associated with y squared. It's associated with what? It's associated with the parentheses. Therefore, it is going to be used to what? Everything that is in the parentheses. So it applies to the x, it applies to the y squared, it applies to the, no, it doesn't apply to the 6 because the 6 is not in the parentheses. And the exponent only applies to the thing that it's next to. Now, I know that's not precise mathematical language, but that's really the way it works. An exponent applies to the thing that it's next to. What's it next to here? The parentheses. What's it going to be applied to? Everything inside the parentheses. Is the 6 inside the parentheses? No. So, what are we going to have inside the parentheses? 1. And since it doesn't apply to the 6, we're going to be left with 6 times 1. Now follow that zero exponent in the problems that are coming up. Just because there is a variable or a parentheses with a zero exponent does not mean everything else gets wiped out and everything else becomes 1. It's just what that zero exponent is associated with, just like any other exponent. Now, let's look at some rules for negative exponents. The first one is a to the negative m equals 1 over a to the m. Now what that's telling you is anything with a negative exponent, by the way, a negative exponent is not a negative number, so don't treat it that way. Let's say that a was negative. And so a negative times negative m is positive. No, it does not work that way. Be real careful. What that negative exponent means is flip the fraction. Now the technical mathematical term is it represents the inverse. But that's kind of hard to think about. It's real easy if I say flip the fraction. Now what's the fraction of a? A is a over 1. So a to the negative m over 1 is going to equal 1 over a to the m. If you look at that real carefully, you'll see that all I have done is flip it. And by the way, you're not going to hear me say inverse very often. You're going to hear me say flip it a lot more than anything else. Now the second rule is essentially the same rule. It's 1 over a to the negative m equals a to the m. So you take your negative exponent, flip everything, and your exponent becomes positive. Now the last rule, a over b in parentheses to the negative m. What does that negative m apply to? What does that exponent apply to? Everything in the parentheses. So since it's a negative exponent, what are we going to do? We're going to flip our fraction, and it's no longer going to be a over b. It's going to be b over a. And our exponent is going to become positive. Now, Mr. Wallace and I handle fractions with exponents in a different fashion. He likes to kind of keep everything where it currently is until the very end, and you've done all the addition and subtraction of exponents and all that. Me, I like to throw everything upstairs. Everything except the coefficient. So leave the units number downstairs. But let's throw the first one. We have on top A, B, C. No need to mention the exponents except for C. C doesn't have an exponent, so what are we going to do there? Okay, good. That C now has an exponent of 1, which we're going to leave there while we're working on this problem. Obviously, we're going to take it off at the end if we need to. But let's start moving everything upstairs. Now, we said we were going to leave the coefficient alone. The D has an exponent. The D has an exponent of negative 1. So we move it from downstairs to upstairs, and what happens to the negative exponent? The exponent is the same, except that it moves from a negative exponent to a positive exponent. Now let's take our e. E to the negative 4 becomes e to the positive 4 as you move it upstairs. Now let's move our f. Our f goes from being f squared to f to the negative 2. Now the thing that we want to do is we want to multiply all our common variables. A, B, C, D, E, F. We don't have any common variables to multiply. And so why don't we just take what we have and start moving the negative exponents downstairs. So A is fine. B has a negative exponent. C, D, and E have positive exponents, so leave them where they are. F has a exponent of negative 2, so let's move that downstairs. Okay, so everything is where it's supposed to be. Our units don't need to be multiplied or divided or anything like that. And all of our exponents are positive. A cubed. C and D have an exponent of 1. They don't need those ones anymore. Yeah, don't put those in your answers when you're doing your homework or taking a test. So those are fine, and our E is fine. Our B has a positive exponent downstairs. Our F has a positive exponent downstairs. And the only other thing we need to do is maybe move over that A a little bit so that it looks nicer. And there you go. That's a little lopsided, but I don't feel like writing that whole thing over again, so that's good enough for me. And let's work on another problem. Okay, we're going to use several rules to solve for this. And one thing I should warn you is I'm having a little bit of trouble seeing those exponents, so be real careful as you're watching this video that you're getting the exponents right. They're the same exponents as in the book. And the first thing that I do, Mr. Wallace does not do this, I do, is I have x to the negative 5, x to the negative 5. What's x to the negative 5 over x to the negative 5? It's 1. Now if you want, you can bring this x to the negative 5 upstairs, and then we're going to have x to the negative 5 plus x to the 5. And we're going to add those two exponents and have x to the 0, which is 1. Do you want to go through all that work? No, I didn't think you did. So when you see things that are common, and remember, you're going to get into trouble if we have plus signs or minus signs on the top or bottom, but we don't. so there's no problem there. And so x to the negative 5 over x to the negative 5 is 1, so you can eliminate that. Now you can put in a 1 right there if you want, and it's 4 times 1 times the rest of this, but that's kind of a waste of time. And so the next thing we're going to do, we don't have anything that's in common with that y, so let's multiply the units upstairs. That's right, 4 times 3 is 12. And let's bring all our variables with exponents upstairs. We have y cubed, and as we move that y from the denominator to the numerator, that positive exponent is going to become negative, so y cubed is going to become y to the negative 3. And let's start multiplying and dividing everything out. Let's start with our units. 12 over 6, which is 2. Then let's multiply all our x variables. We only have 1, so we don't need to do anything there. Let's multiply all our y variables, and they are all negative. That is, the exponents are negative, all of the variables are positive. So we have y to the negative 3, y to the negative 2, y to the negative 3. So what are we going to do? We're going to add our exponents. And that is going to be y to the negative 8. And so we have 2. And let's read this in the proper order, not the way it's listed here. But we have 2x cubed y to the negative 8. And so we need to move that y downstairs. Good, and we have y to the positive 8 downstairs. Now, that's actually our answer, but let's clean that up so it looks better. Let's just move the 2 closer to the x. And there you go, that's the same answer, but it just looks a lot better. 2x cubed over y to the 8th. Now let's try another problem. Okay, we have several things going on here in this problem. And before we move our variables upstairs, why don't we take care of this parentheses first? And so this exponent applies to what? Everything inside the parentheses. That exponent is applicable to the parentheses, which means it is related to everything, or it's applied to everything within the parentheses. So it's a power of a power, which means we're not going to add the exponents, we're going to multiply the exponents. Hey, before we do that, why don't we give all the exponents without, or all the variables without an exponent, give them an exponent. We're going to need 1 there. Let's see, I don't think that one needs any. Let's just apply that. Yeah, both those a's needed a exponent of 1. And let's see. And the reason why we do that is I don't want to be multiplying negative 2 times 0 or some crazy thing, or just skip over it altogether. If I put that 1 there, that reminds me that I have got to apply that negative 2 to everything in here. So we're going to have negative 2 times 3 is negative 6, and negative 2 times 1 is negative 2. Good? Now, 3 also has an exponent of 1, and maybe I should have put that there, but that 3 is going to end up with an exponent of negative 2. Don't forget to do that. I can't tell you how many students apply these power of powers, or they apply exponents, they apply whatever to everything except the units. Make sure that if it needs to be applied to the units, that you're applying it to the units. So let's do all that right now. Oh, good. And I'm going to leave my units where they are. I'm going to bring the variables on the bottom upstairs. So let's bring the a upstairs. Good. A to the negative 4 becomes a to the positive 4. And b to the 0 is going to be, well, we don't need to bring it upstairs because it's 0. Why don't we just eliminate it? And so we have all of our variables upstairs. We're leaving our units alone for right now. And let's see. Let's add all of our a's. We got a to the negative 2. We got a to the positive 1. And we got a to the positive 4. So a to the negative 2 plus 1 plus 4. We have a to the 3, or a cubed. And now let's multiply our b's. We have b to the negative 6 and b to the negative 3 is b to the negative 9. Now we've done all our work upstairs, and this is what I like to do. I like to bring all my work upstairs, complete it, and then start sending my numbers and my variables with negative exponents downstairs. So the first thing I'm going to send downstairs is my units. 3 to the negative 2 comes downstairs, and 3 to the negative 2 becomes 3 to the positive 2. And of course, we're going to multiply times that 2, but not now. We have a variable. We have our b to the negative 9 that needs to come downstairs. So why don't we bring that downstairs? B to the negative 9 is going to become b to the positive 9. And our work upstairs is complete. And there are no negative exponents or any work that needs to go back upstairs. So why don't we finish our work in the denominator, or downstairs? 3 squared is 9, and 9 times 2 is 18. And that is our answer, a cubed over 18b to the 9. And the only thing we want to do is clean up that line a little bit. There you go. That looks pretty good. Nothing to complain about there. And let's do one last problem. Okay, this is pretty wild, but it's not really anything new. And let me ask you a question. If you were presented with a problem like this, a problem you've never seen before, I'm sure most of you students have not seen a problem like this before, how would you attack it? If you saw something like this on the SAT, how would you attack it? That is to say, where would you start? Okay, what's the rule for starting? PEMDAS, parentheses, exponent, and so on. And so we start at the parentheses. Which one? There's 2 parentheses. We start on the innermost parentheses. So there's no work to do inside these parentheses. There's no parentheses up here, by the way. Let's go back down here. There's no work to do in here. So let's apply this negative 3 to the y and to the x, and the 9 is not in the parentheses, so leave that alone. So apply this negative 3 to these 2 exponents, that is, multiply them. And since it was a negative exponent that we were applying, our positive exponent is going to become negative, and our negative exponent is a negative exponent times a negative exponent is a positive exponent. And I think I told you before that a negative exponent times a negative exponent is not a positive exponent. Actually, it is. I think what I said, or what I meant to say, is a variable with a negative exponent times a variable with an exponent. It doesn't end up being a negative exponent. Hopefully that's what I said. But anyways, we have these 2 variables. They need to go upstairs. And so let's take them one at a time And I'm going to bend this parentheses out a little bit more so that we have more room. Let's bring the x up first. And x to the negative 6 is going to become x to the positive 6 when we bring it upstairs. And y to the positive 6 is going to become y to the negative 6. And some of these numbers and exponents are getting pretty tiny. You should be able to see that on a full screen on your computer. If you're looking at that on your smartphone, you might have a little bit of trouble. So let's multiply our numbers upstairs. That would be 3 times 6 is 18. And so let's start multiplying our variables. We have 3 x's right here, and right here. And I see an x to the positive 6 here and an x to the negative 6 here, which is x to the 0. So why don't we just eliminate those? Okay, and x to the negative 2 is all we have left. So let's leave that x alone, at least for now. And then our y's. We have 1, 2, 3 y's. Let's add all those variables. Yeah, x to the negative 3. And then I got z to the positive 3 and z to the negative 3. What's going to happen there? You already know. X to the 3 minus 3 is 0, and that's a 1, and it eliminates itself. Wow, we're down to 2 variables, and our units are 18 over 9. That's going to be 2. And now we've done all the work within the parentheses, and this is the second parentheses. We've done all the work within that parentheses that we can. And so let's apply the exponent. Now you can imagine if we tried applying that exponent earlier, that would have been a nightmare. But right now it's not that bad. Let's apply it to the 2. Good. X to the negative 3. And negative 3 times negative 2 is positive 6, x to the positive 6. And y to the negative 3 times negative 3 is positive 9. And now the only thing I have upstairs with a negative exponent is our units, 2 to the negative 3. Let's bring that downstairs. Boy, that's looking better all the time. You remember what that looked like when we first started? Wow, this is looking pretty good. Anyways, there's nothing we can do upstairs. 2 cubed is 8, and that is our answer. Let's clean up that division bar a little bit. x6, y9 over 8 is our answer. And that is it for this lesson. Make sure you do your homework. Now, one curious thing in this lesson, and even in the homework, all the exponents, when we're all said and done, are positive. That doesn't necessarily need to be the case, although it is for this Algebra 1 lesson. But they could tell you, I want all the variables in the denominator. Okay, well that would make this problem different. They could tell you, I want all the variables in the numerator, and that wouldn't make anything different for this problem. But they could say, I want all my variables with a negative exponent. And that, of course, would make this different. And that should be an easy thing to do. And what I recommend is that you end up like this. Go back and read the question. Where did they want the variables? Did they want the exponents positive or negative? And that's a very simple thing to do once you have it in this format. So do your homework, and we'll see you next lesson.